So from the term itself, so when we say homogeneous, okay, so that means there is a commonality, okay, so among the different terms involved in a given differential equation. So in a differential equation, so whose format will be m of xy dx plus n of xy dy, and it is equals to 0. So if the m function of the lambda x and lambda y is equal to lambda raised to n times m function of x and y, and the n function of lambda x and lambda y is equals to the lambda raised to n multiplied with the n function of x and y, is said to be, or then the given differential equation is said to be homogeneous with degree of homogeneity n. Okay, so meaning if we're going to introduce a variable, okay, so which is lambda, and then we're going to change x to lambda x, and then y to lambda y, and then if we can factor out lambda, okay, so from the given differential equation, so whatever would be the exponent of lambda, then the given equation is said to be homogeneous. And then the exponent will correspond to the degree of homogeneity of the given equation. So once we were able to classify, or once we were able to identify that the given equation is said to be homogeneous, then there are two methods of solution that we can follow, or two methods of substitution that we can follow by merely looking at the m function or the n function. So if the m function is simpler than the n function, so meaning there are a smaller number of terms, okay, so for the m function as compared to the n function, then we use x is equals to vy, and then we derive dx to be equal to the product rule for vy, so which would be v dy plus y dv. However, if the n function is simpler, okay, or meaning it has a smaller number, okay, of terms as compared to the m function, and then so we let y is equals to vx, and then of course dy will be equal to v dx plus x dv. So that's how we go with the methods of solution, or the substitution that we're going to use for homogeneous equation. Now we have the degree of homogeneity. So how do we classify? Okay, so how do we classify or how do we identify the degree of homogeneity of a given homogeneous equations? Okay, as long as we were able to factor out lambda, okay, so from the given equation, and then that makes it homogeneous. Okay, so that makes a given equation homogeneous, but if not, okay, so that is a non-homogeneous equation. But then we have the degree of homogeneity. So the idea for the degree of homogeneity is very useful in the process, okay, of finding the general solution of a differential equation. Because once we know the degree of homogeneity, so later on, so that would be the term, okay, so that we can cancel out later on. Okay, so but for the meantime, how do we identify the degree of homogeneity? So in identifying the degree of homogeneity, so we have to take note that we need to substitute, okay, so x to lambda x, and then y to lambda y. Okay. So for example, for number 1, so is this a homogeneous equation or not? Okay, so we have y dx plus x dy. So changing y, so to lambda y, and then lambda y dx, then plus, so changing x to lambda x dy is equals to 0. And then from here, so lambda is common to both, so that is lambda, multiply it with y dx plus x dy is equal to 0. So from here, so we were able to factor out lambda, and then we still retain, okay, so the original equation, so which is y dx plus x dy is equal to 0. So thus, making this one homogeneous. And the degree of homogeneity, okay, so the degree of homogeneity is equal to 1. So because the power of lambda, it's just 1. Okay, so the degree of homogeneity then is equal to 1. So that's how we classify if it is homogeneous or not. Okay, so by changing x to lambda x and y to lambda y, and then afterwards, if we can factor out the lambda, so regardless whatever would be the exponent of lambda, then that makes it homogeneous equation. Okay, but if we cannot factor out lambda, okay, so from the differential equation, then that makes it non-homogeneous. So number 2 is another homogeneous equation. Okay. So doing that, so we can change x so to lambda x raised to 3, or so lambda x so raised to 3 plus lambda y raised to 3 dx, then minus 3 times lambda x, then lambda y squared dy is equals to 0. So this would give us lambda cube x cube plus lambda cube y cube dx minus 3 lambda x lambda squared y squared dy is equals to 0. So we can factor out lambda cube here. So resulting to x cube plus y cube dx. And then from here, so we can make it 3 lambda cube, then x times x squared, so x, and then we have y squared dy is equals to 0. And from here, so we can factor out lambda cube, so to be x cube plus y cube dx, then minus 3x y squared dy is equals to 0. And thus, again, so this is the original equation. So this is the original equation, x cubed plus y cubed dx minus 3xy squared. So similar with the original equation, and then we were able to factor out lambda cube. So therefore, its degree of homogeneity is equal to 3. Okay, so because of that, degree of homogeneity is 3. So how about this one? Okay, so let's say we have x, so this is lambda x, then y is lambda y dx minus, okay, so lambda x plus 2 lambda y squared dy is equal to 0. So this would make it lambda squared xy dx, and then minus, so I can factor out lambda here, so lambda, so x plus 2y squared dy is equals to 0. So lambda squared xy dx, so minus, it's the same as lambda squared x plus 2y squared dy is equals to 0. Then factoring out lambda square, So that would give us xy dx minus x plus 2y squared dy is equal to 0. So again, so this xy dx minus x plus 2y squared dy, so multiplied with lambda squared, so our degree of homogeneity is equal to 2. Okay. Okay, so what if we are given this? So x plus y sine y over x dx minus x sine y over x dy is equals to 0. This is still a homogeneous equation. Okay, so we just follow the substitution. So x, so lambda x plus lambda y, then sine lambda y over lambda x. So again, as long as we can factor out lambda from the entire equation, then that makes it a homogeneous equation. Then minus lambda x sine lambda y over lambda x dy. So by the way, so this is multiplied with dx is equal to 0. So I can factor out lambda here. So lambda, and then so x plus y sine. By the way, so lambda and lambda would be cancelled out. So we still have y all over x here. Then minus lambda x sine. So again, so lambda and lambda would be cancelled out. So y all over x dy is equals to 0. So we can factor out lambda. So giving us, so x plus y sine y over x dx, and minus x sine y over x dy is equals to 0. So again, so x plus y sine y over x minus x sine y all over x dy is the same as the original equation. So we only have a lambda, a factor out lambda, and its degree of homogeneity is 1. Okay, so because of the power of lambda. Okay, so we were still able to factor out lambda. Okay, so that makes it homogeneous. Actually, all of these are homogeneous. So later on, we'll have an example of what is a non-homogeneous equation. So number 5. Okay, so we have x minus y ln y plus y ln x dx plus x ln y minus ln x dy is equal to 0. So what is the degree of homogeneity of this one? Okay, so is this even homogeneous equation? So let's try to find out. So we have lambda x minus lambda y ln lambda y plus y is lambda y ln lambda x dx, and plus lambda x ln y, so ln lambda y minus ln lambda x dy is equals to 0. So in here, I can factor out lambda. So that would give us x minus y ln lambda y plus y ln lambda x dx. And so plus lambda x. So in here, it's still ln lambda y minus ln lambda x dy. So as you can see here, although we can factor out lambda, but then we still have this. So lambda x or lambda y, lambda x, lambda y, lambda x. Okay, so that makes it possible that it's not a homogeneous because we were able to retain, okay, so lambda, so within the differential equation. But then, so this is natural logarithm, so we can apply some properties if we can cancel out those lambda. So let's try to do it. Okay. So I can factor out y first. So from the 2, so this is minus y. Or I'll make this one plus y. Okay. And then that would make it, so negative y ln lambda y. So divide it with y. So that would make it negative ln lambda y. And then the positive y, so that would make it plus ln lambda x dx. Then plus lambda x ln lambda y minus ln lambda x dy is equals to 0. So lambda then would be x plus y. And then, so we can make this one as, so ln lambda y. So since it's negative, so we can combine the two. So this is the same as lambda or ln lambda x all over lambda y dx. And plus lambda x. And this would be ln lambda y all over lambda x dy is equals to 0. And from here, so we can already cancel out lambda and lambda. And then we can factor out lambda here already. So lambda, then this would become x plus y lambda x over y dx. And plus x ln y all over x dy is equal to 0. Or this is the same as x plus y ln x minus y ln y dx. And plus x ln y minus ln x dy is equals to 0. So what can we see? So this is x, negative y ln y, and positive y ln x, then x ln y minus ln x dy. So which is the original equation free from lambda. Because lambda is outside, we were able to factor out lambda, whose degree of homogeneity will be equal to 1. Okay, so still this equation is homogeneous with degree of homogeneity which is equal to 1. So how about number 6? So we have a square root. So again, we change y to lambda y minus, so lambda x square. So I'll make this one lambda square x square plus lambda square y square, then multiplied it with dx minus lambda x dy is equals to 0. So we have lambda y minus, so we can factor out lambda square, then x square plus y square dx minus lambda x dy is equals to 0. But then the square root of lambda squared is lambda, and then we retain the square root of x squared plus y squared dx minus lambda x dy is equals to 0. So you can see here, So lambda is factorable, so leaving us with y, then minus the square root of x squared plus y squared dx, then minus x dy is equals to 0. So this is the original equation, and then lambda, the degree of homogeneity, is equal to 1. Okay, so with the power of 1 there. Okay, so that's how we find the degree of homogeneity, and that's how we classify whether a given equation is homogeneous or not. Okay, so changing x to lambda x and changing y to lambda y, and after doing that, if we can still factor out lambda, then that makes it homogeneous. And then the power of lambda will correspond to the degree of homogeneity of the given homogeneous equation. Okay, so what's an example, as I've mentioned? So let's say we have a simple equation. So let's say it will be x plus 1, okay, so dx plus y dy is equals to 0. So this is a non-homogeneous equation. So once we change this x to lambda x, so plus 1 dx, then plus lambda y dy is equals to 0. So as you can see here, I cannot factor out lambda because of the presence of this 1. Okay, so there's no lambda for 1. So therefore, I cannot factor out lambda. That makes it a non-homogeneous equation. So that's how we find the degree of homogeneity. Actually, in the degree of homogeneity, so you can just simply look at each term. Okay, and then what would be the power of each term? So will correspond to its degree of homogeneity. So for example, for number 1, so we have y dx and x dy. So the degree of this is 1, the degree of this is 1 as well. So making the degree of homogeneity equal to 1. So meaning the degree or the total degree for each given term is the same. So that makes it homogeneous. In this case, number 2, there are 3 terms involved. So this is x cubed, y cubed, and then the 3xy squared. So x cubed has a power of 3. Y cubed has a power of 3. In this case, there are 2 variables. So x has a power of 1 and then y has a power of 3. But if we add the 2, that makes it 3. Okay, so meaning, so the total degree for each given term is 3. So that's its degree of homogeneity is 3. So number 3. So this one, x is 1, this is y is 1. So therefore, that is 2. And then if we're going to expand this, so x plus 2y raised to 2. So expanding this, so that is x squared plus 4xy and then plus 4y squared. So we have a power of 2. So 1 and 1, that is 2. And then y squared, that is 2. So everything is 2. So making the degree of homogeneity equal to 2. So that's the simplest one. And then this one, it has a power of 1. Y is 1. So this one would cancel out. Okay, so because lambda y and lambda x, so lambda would just be cancelled. So this is 1. So therefore, degree of homogeneity is 1. For number 5, so this is 1, this is 1, 1, this is 1. Then, since both are ln, so ln x over ln y, so it will cancel out the lambda there. So giving us a degree of homogeneity of 1. So from here, so we have 1. Actually, in here, we can see 2, but then there's a square root. Okay, so this is 2. But remember, a square root is 1/2. So 2 times 1/2, which is 1. So similarly with this one, 2 times 1/2, which is 1 as well. So the degree of homogeneity will be 1. So we have to perform what is indicated on the given differential equation. Okay. So the degree of homogeneity can actually be seen on the homogeneous equation. But then, the technical way on how to do it is by changing x to lambda x and changing y to lambda y. Okay, so that's how we find the degree of homogeneity. So now let's apply. So what's the purpose of the degree of homogeneity later on? So for example, number one, okay, so I'm not going to check anymore. So whether this is homogeneous or not, these are actually all the or the previous examples are what we are going to solve. Okay, so for this one. So we have x cubed plus y cubed dx minus 3xy squared dy is equals to 0. So now, in homogeneous equation, so we're going to identify what are we going to substitute. So whether we're going to substitute x is equals to vy or y is equals to vx. So we choose. So we choose x is equals to vy if the m function is simpler than the n function. So what do I mean by simpler function? So our m function here, so this is m, this is n. So it has two terms. So x cubed plus y cubed. N function has only one term. Okay, so since n function has only one term, then we follow this. Okay, so we look at the differential actually. So if the differential is dy, okay, so that is what we're going to substitute. We're going to let y is equals to v times x. So why are we doing that? Okay, so because once I derive this one, so the derivative of this, so dy is equals to v dx plus x dv. So look at this. So there are two terms, v dx and x dv. So this is a single term. Okay, so one term. So multiply it with two terms. So the resulting terms would be two terms. But then if we let m, or if we're going to let x to be equals to vy, so that is x is equals to v dy plus y dv. So look at this. So this is two terms. Okay, so m function has two terms, x cubed and y cubed. And then if we're going to let x to be equals to vy, dx, there are two terms as well for dx. So 2 times 2, the resulting number of terms would be 4. Okay, so that makes it complicated. Okay, unlike if we're going to use y is equals to vx, the resulting terms would only be 2. But if we're going to use m function, then the resulting term will be 4. Okay, going back. So we're going to use y is equals to vx. So we're going to let y is equals to vx. So therefore dy is equals to v dx plus x dv. So we substitute then. So for x, so it will just be x cubed. Then plus, so for y, so y is vx. Okay, so vx raised to 3, that is v cubed x cubed. Or, yeah, v cubed x cubed. And multiply it with dx. Then minus 3, so we retain x. So y squared is vx, so v squared 3x v squared and x squared dy is equals to 3. But again, let me remind you that the degree of homogeneity of this is 3. Okay, degree of homogeneity is 3. Okay, so now that we have x cubed plus v cubed x cubed dx minus 3x v squared x cubed dy, or sorry, dy is v dx, so v dx plus x dv is equal to 0. So we can see here, so we can factor out x cubed on the first function. So we have x cubed, so multiplied it with 1 plus v cubed, then dx, then minus, I'll have 3, so x times x, supposedly it's x squared. Okay, so it should be x squared. Okay, so v squared x squared. So for y squared, it's vx or v squared x squared. So making it 3x cubed, and then v squared v dx plus x dv is equals to 0. So this is the idea for the degree of homogeneity. So if we have degree of homogeneity, which is 3, so therefore, and then we let y is equals to vx, a term, okay, so which a power of 3 can be cancelled out from the given equation. In this case, what is common to both is actually the x cubed. So x cubed and x cubed on the second term, so can be cancelled out. So if we can multiply or divide everything by x cubed, so it will cancel out. Okay, so this is related to the degree of homogeneity of 3. Okay, so if the degree of homogeneity is 2, then there is a term with a power of 2 that can be cancelled out. Okay, so that's the idea why we need to know the degree of homogeneity. It's because if we're not going to do this one, our solution will be complicated. Okay, so it's always like that. So after substitution, so there should be cancellation that would happen. Okay, so the cancellation in this case would be in terms of x cubed. And thus leaving us to have 1 plus v cubed dx, then minus, so 3v squared v dx plus x dv is equal to 0. Okay, so after the cancellation, okay, so substitution, then cancellation, so we perform the operation. So that would be, so we distribute, so this is dx, then plus v cubed dx, and then minus, so 3v times v dx will be 3v cubed dx, and then minus 3x v squared dv is equals to 0. So we have dx plus v cubed dx, and then minus 3 v cubed dx minus 3x v squared dv is equal to 0. So from there, so we can now perform the operation, so which is, so dx minus, so v cubed minus 3v cubed, so that is minus 2v cubed dx, then minus 3x v squared dv is equals to 0. So after that, so we can factor out dx, so that would make it 1 minus 2v cubed dx, and minus 3x v squared dv is equals to 0. So once we are done, okay, so after performing the operations involved, so homogeneous equation will be transformable into a separable equation. Okay, so this is the process. So we substitute, so substitution, and then there will be cancellation of the degree of homogeneity. Then we perform the operation. So after doing those three steps, okay, so substitution, okay, so remember this. So we have the substitution, cancellation, we have the cancellation, and then performing the operation. Performing the operation, it will be transformed into a separable equation. So meaning, so we can now separate these. So how do we separate it? So this is dx. So therefore, what should be multiplied here would be dx. And this is dv. So what should be multiplied here would just be dv. So this is dv. So what is in excess is x. And what is in excess with dx is this 1 minus 2v cubed. Okay? So we can now do the separation. So that is, so dx, and then all over dx. Okay? Then minus 3v squared dv all over, so this one. So which is 1 minus 2v cubed is equal to 0. So that makes it homogeneous. Okay? So that makes it a homogeneous equation. So this is what happened here. So dx over x minus 3v squared. Okay, so 3v squared dv all over 1 minus 2v cubed is equals to 0. So now we do the integration. So what would be the integration? So dx over x is ln x. But how about 1 minus 2v cubed? So in here, our u will be 1 minus 2v cubed. So our du will be negative 6v squared dv. So we have v squared there. So our neutralizing factor, so let's say we're not going to use the 3 there. So our neutralizing factor will be 1 all over 6. Okay, we already have, okay, so I'll do the negative 1 over 6. Okay, so let us now, so integrate, so 2 dx over x minus, so 3v squared dv over 1 minus 2v cubed. So the integral of that, so will be ln x, and then I'll have a negative 3. So the neutralizing factor is negative 1 over 6. So ln of 1 minus 2v cubed. Okay. And then multiply it with, or is equals to c. So ln x then, so that would be plus 1/2 ln 1 minus 2v cubed is equal to c. So we're multiplying everything by 2. So that is 2 ln x plus ln 1 minus 2v cubed is equals to c. And ln x then, so will be raised to 2. So plus ln 1 minus 2v cubed is equals to c. So we can combine, so by applying properties of logarithm, so ln x squared times 1 minus 2v cubed is equals to c. Then we exponentiate both sides. So giving us x squared 1 minus 2v cubed is equals to c. But then, so this is v. Okay, so remember that what we substitute is this one. So that y is equals to vx. So, but y is equals to vx. So therefore, v is equals to y all over x. So x squared, 1 minus 2. So we have v cubed. So that would make it y cubed over x cubed. Then will be equal to c. So x squared then. So we can combine the two. So the LCD is x cubed. So times 1 is x cubed minus 2y cubed is equals to c. Okay, so that will make it, so x squared, x cubed, so we still have 1 there. So that will make it x cubed minus 2y cubed all over x is equals to c. And thus x cubed minus 2y cubed is equals to c times x. And that makes the solution of the given differential equation. Okay? So homogeneous equation is a bit longer. But the next topic is longer than these. It's even longer than these. Anyway, so let's have example number 2. So we have xy dx minus x plus 2y raised to 2 dy is equals to 0. So which is less complex? It's xy dx. So from there to xy dx, so this is our clue. It's the dx. So we're going to substitute x then, so to be equal to vy. So our derivative then, so will be v dy plus y dv. So we substitute, so x is vy times y. Okay, so vy, or sorry, so x is vy times y. So that would make it vy squared. Okay. So vy squared, then dx will be v dy plus y dv. Okay, so again, so x is vy times y would be vy squared. Then dx is v dy plus y dv. Then minus, so x is vy, okay, so vy plus 2y squared dy is equals to 0. So that's the substitution. Okay, so the first is substitution. So after is cancellation. But to cancel it out, so something must be cancelled out. But then, so let's try to figure out. So our degree of homogeneity here is 2. Okay, so maka-cancel dapat dito will be 2. Okay, or a term raised to 2. So v dy plus y dv, then minus, so you can see here, so y is factorable. So that would make it v plus 2, then raised to 2, dy is equals to 0. So this is the same as vy squared. So v dy plus y dv minus, so y raised to 2 is y squared, and then v plus 2 raised to 2 dy is equals to 0. So since our degree of homogeneity is 2, so in here, so we can see that we can multiply everything by 1 over y squared. So y squared, y squared, y squared will be cancelled out. Okay? So that's leaving us to have this one. So v times v dy, so we'll have v squared dy, and then v times y dv, so that would be plus vy dv. And then expanding this, so negative v squared plus 2 times v times 2, 4v plus 4 dy is equals to 0. So v dy, v squared dy plus vy dv minus v squared dy minus 4v dy minus 4 dy is equals to 0. So v squared dy minus v squared dy is 0. So that's giving us a vy dv. Then I can factor out minus 4. So giving me a v. So negative 4v dy. So we'll have dy there. So negative 4 dy. So I'll just have v and then plus 1. Okay, so that's negative 4 dy, negative 4, or negative 4v dy, and negative 4 dy is equals to 0. So now, so which is in excess? So this is vy dv. So this is dv. We are in excess of y. Then minus 4v plus 1 dy. So we are in excess of v plus 1. Okay, so we are in excess of v plus 1. So thus, we'll have v dv, then divide it with v plus 1. Then minus 4 dy divided with y. So v dv over v plus 1 minus 4 dy over y is equals to 0. So now that it is a separable equation, so we integrate it. But then we have v dv over v plus 1. So how do we integrate this? So this is an improper fraction, so we can divide. But if you don't want to divide, so we can make this one as the same as v plus 1 minus 1. Okay? So 1 minus 1 would be 0. So that is over v plus 1 dv. Then minus 4 dy over y is equals to 0. So v plus 1 minus 1, 1 minus 1 is 0. So therefore, it's the same as v over v plus 1. But then we can separate these two as v plus 1 over v plus 1, then minus 1 all over v plus 1. So we separate it into two terms. So multiply it with dv. So minus 4 dy over y is equals to 0. So this makes it 1 minus 1 over v plus 1 dv minus 4 dy over y is equals to 0. So we can now integrate this one as the integral of dv. So 1 times dv, it's just v. And minus, this would be ln v plus 1. Then minus 4 ln y is equal to 0. And then, so we can make this one as or this should be C. So since we have integrated it already, I'm going to combine ln, okay, or I'm going to transpose ln to the right hand side and C to the left hand side. So this would give me V. So C, transpose it, negative C supposedly, but negative could be absorbed by C, so I'll just make it plus C. Okay, so V plus C. So regardless, okay, so kahit transpose natin yung C, it's still positive. No? And then that would make it, so ln so V plus 1, and then plus 4 ln y. So combining the two, but we can make this one as ln y raised to the fourth. And then, so we combine the two, so v plus c is equals to ln v plus 1 raised to, or times y raised to 4. And we exponentiate both sides, so this is the same as c e raised to v is equals to, this is e raised to v times e raised to c. So e raised to c, it's still c, so that makes it c e raised to v. And then this would be v plus 1, then y raised to 4. But we made an assumption that x is equals to vy. So therefore, v is equals to x over y. So we substitute, so c e raised to x over y is equals to, so v is x over y plus 1 times y raised to 4. Or I'm going to interchange the two. So or y, so that would be x plus y times y to the fourth is equals to c e raised to x over y. So that would be x plus y times y cubed is equals to c e raised to x over y. So that will be our final answer then. So x plus y times y cubed. Okay, so x. Okay, so that will be our final answer. So x plus y times y cubed is equals to c e raised to x over y. So let's have another one. So we have x plus y sine y over x dx minus x sine y over x dy. So there are two terms, 1, 2, there's only one term. So therefore, I'm going to let, so y is equals to vx. So dy then would be v dx plus x dv. So we substitute x, or we retain x, then we substitute y, so to be vx plus vx sine, our y is vx over x, so vx over x dx, and minus x sine y is vx over x, and then our dy is v dx plus x dv. v dx plus x dv is equals to 0. So now x would be cancelled out, x would be cancelled out. And then the degree of homogeneity of this equation is 1. So therefore, we're expecting to cancel out. In this case, so we can factor out x here. So as that will become 1 plus v sine v dx, and minus x sine v times v dx plus x dv is equals to 0. So multiplying everything by 1 over x, okay, so which is related to this. So x, and x would be cancelled out. So leaving us to have, so 1 times dx, it's dx plus v sine v dx minus, so sine v times v dx is the same as v sine v dx, then minus x sine v dv is equals to 0. So v sine v dx minus v sine v dx will be 0, and thus leaving us to have dx minus x sine v dv is equals to 0. So this is a bit shorter. So we can now have dx over x minus sine v dv is equals to 0. Because x is in excess here, so it moved down. So dx over x minus sine v dv. So integrating both sides, so leaving us to have ln x, then minus integral of sine v is plus cosine v is equals to c. But then we let y is equals to vx. Okay, so that's our assumption that y is equals to vx. So therefore v is y all over x. So that makes it ln x plus cosine y all over x is equals to c. So that will be our final answer for this one. So this is a bit shorter. Okay. So we have this one. So x minus y ln y plus y ln x dx plus x ln y minus ln x dy is equals to 0. Okay, so what are we going to do with this? Okay, so this one involves 3 terms. This one involves 2 terms. So I guess it's safe to use y is equals to vx. So dy would be v dx plus x dv. But I would prefer to perform or simplify this first. So before substitution. So because there are ln's, okay, natural logarithm involved. So what I can do is simplify it first before the substitution. So y or x and minus, I can factor out y here. So this would make it ln y, then minus ln x. Okay, so factor out negative y, so that would make it positive ln y, and then minus ln x dx. Then plus x ln y minus ln x dy is equals to 0. Then we can make this as x minus y, then ln y all over x dx, then plus x ln y over x dy is equals to 0. Okay, so now I can substitute. Okay, so y in terms of vx, so that would give us, so x minus Vx ln, so Vx over x dx, then plus x ln Vx over x, and then this one is multiplied with v dx plus x dv is equals to 0. So x and x would be cancelled out there. And then, so we can factor out x here. So which makes it 1 minus v ln v and dx plus x ln v multiplied it with v dx plus x dv is equals to 0. And then again, so we can cancel out the degree of homogeneity. So we have identified that the degree of homogeneity of this is 1. So therefore, I'm going to multiply it by 1 over x. So 1 over x would be cancelled, x, and 1 over x. So leaving us to have, so 1 times dx, it's dx, minus v ln v dx, then plus, so ln v times v dx is v ln v dx, and then plus x ln v dv is equals to 0. So x ln v dv. So negative v ln v plus v ln v will be cancelled out. So giving us to have dx plus x ln v dv is equals to 0. So x is in excess in ln v dv, so it will move down. So dx over x plus ln v dv is equals to 0. So dx over x plus ln v dv is equals to 0. So dx over x is ln x, but ln v dv, so we can use integration by parts. Our u will be ln v, our dv will be, or our dv is dv, okay? And then our du here would be 1 over v, and then our v is v. So dx over x, so we can integrate it right away. Okay, so dx over x is ln x, and then uv, so plus v ln v minus the integral of v du, so which is v, so by the way it has dv here, so v times dv over v is equals to c. So v over v would be cancelled out, so that's giving us ln x plus v ln v minus v is equals to c. Okay, so integral of dv, it's just v. So since there are two ln here, so I can make this one as ln x plus, so using properties of logarithm, this is ln v raised to v is equals to, so transpose v, so it will become positive v plus c. Then I can combine the two, so as ln x times v raised to v is equals to v plus c. So we exponentiate both sides, so giving us x v raised to v is equals to c e raised to v. Okay, so ev, then e raised to c is c ev. But we made our assumption for y is equals to vx. So therefore v is y all over x. So x times v is y all over x times raised to y all over x is equals to c e raised to v, which is y all over x. And we just leave it as is. So x times y over x raised to y over x is equals to c e raised to y all over x. And for our last example, so we have y minus the square root of x squared plus y squared dx minus x dy. So our degree of homogeneity is 1. So we have how many terms? 1, 2, 2 terms versus 1 term. So therefore, we let y to be equal to vx. And then dy will be v dx plus x dv. So we substitute y. So y to be vx minus, so x squared plus y squared is vx, so v squared x squared. And times dx minus x. Our dy is v dx plus x dv is equal to 0. So vx then, so minus, I can factor out x squared here. So leaving us 1 plus v squared dx minus x times v dx plus x dv is equals to 0. So vx, so square root of x squared is x as well. So x, the square root of 1 plus v squared dx minus x times v dx plus x dv is equals to 0. Again, do not distribute unless you were able to cancel out. So x times, so we can factor out x, v minus square root of 1 plus v squared. Then dx minus x, v dx plus x dv is equals to 0. So this is where the degree of homogeneity enters. So we have 1 over x, again, so in relation to the degree of homogeneity of 1. So again, do not distribute unless you were able to cancel out. Okay, so otherwise, your solution will be complex. It would still be okay, but then it will become complex and difficult to follow. So x, and x will be cancelled out. Then this is the time that we distribute. Okay, so that is v dx minus the integral of 1 plus v squared dx, then minus v dx minus x dv is equals to 0. So v dx minus v dx would be 0, and giving us a negative, okay, so negative the square root of 1 plus v squared dx minus x dv is equals to 0. Okay, so both are negative, so I can multiply both sides by negative 1 to give us positive 1 plus v squared dx, then plus x dv is equals to 0. So we are in excess of this, we are in excess of x. So they will just interchange. So dx over x plus dv over square root of 1 plus v squared is equals to 0. So dx over x is ln x, but then we have dv over the square root of 1 plus v squared. Okay, so how are we going to treat this one? So this is by, we can use trigo substitution here. Okay, so for dv over the square root of 1 plus v squared. Okay, so 1 plus b squared, so that would be tangent. Right? So if we're going to let v is equals to tangent theta. So it follows then that if this is theta, so tangent is opposite, which is v, adjacent is 1, so v over 1, so tangent theta, so therefore this one will be 1 squared plus v squared. So v then is equals to tangent theta. And so what we want is what is dv. Okay, so dv is derivative of tangent, which is secant squared theta d theta. But then what is square root of 1 plus v squared? So looking at our triangle, so we can draw that hypotenuse over adjacent, so which is secant. Okay, so secant theta is the same as square root of 1 plus v squared all over 1. Or just simply secant theta for the square root of 1 plus v squared. Okay, so we substitute. So this would be dx over x is ln x. Then, or we substitute first. So ln x or dx over x so dx over x, dv is, we change v or dv into secant squared theta d theta all over the square root of 1 plus v squared, so which is secant theta. Then it's equals to 0. So this is the same as dx over x plus secant theta d theta is equals to 0. So now we integrate. So dx over x is ln x. Then secant theta, so would be ln of secant theta plus tangent theta is equals to c. So we can combine the two as ln of x times secant theta plus tangent theta is equals to c. So we exponentiate both sides. So leaving us to have x secant theta plus tangent theta is equals to c. But secant theta is equals to square root of 1 plus v squared. And tangent theta is equals to v. So we substitute. So x secant theta is square root of 1 plus v squared. And then plus secant theta or tangent theta is v is equals to c. But then again, so we made some substitution that y is equals to vx. Y is equals to vx. So therefore, v is y all over x. So x times the square root of 1 plus, so v is y squared all over x squared plus our v is y all over x is equals to c. So combining, so x, this is x squared plus y all over x is equals to c. So we can get x squared plus y squared. So the square root of x squared at the denominator is just x, then plus y all over x. So distributing x, so this would cancel out all the excess there. So giving us the final answer to be x squared plus y squared plus y is equals to c. So this is our final answer. And that is all about homogeneous equations. Okay? So again, so in summary, so how do we solve, okay, so homogeneous equation? Okay, so we start by identifying what is the degree of homogeneity, and then followed by identifying the substitution that we're going to use. If the m function is less complex, then we use x is equals to vy. If the n function is less complex, so we use y is equals to vx. So after that, so we substitute. Okay, so we substitute our assumption to the original differential equation. But take note, we do not perform the operation first. Okay, so we need to factor out, okay, the term which has a power similar to the degree of homogeneity, because it will cancel out. So once we were able to cancel out the term which involves the degree of homogeneity, then that is the time that we distribute. So after the distribution or performance of the operation, the equation will always be transformable into a separable equation. Okay, so it is always a separable equation. And then, so once we separated it, so we do the integration so to find the general solution. So that's how we solve homogeneous equation. So next time, so we will be proceeding with differential equations linear in two variables. So we will still be using the principles of homogeneous. And this time there will be two substitution that we're going to use. It's a bit longer. Homogeneous is longer. Linear in two variables is longer as well. Okay, good day.